Alright, so let's start with Kirchhoff law. So this is the first Kirchhoff law. Basically, it's saying that if we have a couple of wire, for example, this is two wire, they are connected at a point here, let's call it A, and then from point A, there are also several wires coming out. Now, if we have a current coming into a point A, let's call it I1, and then the next one also coming into point A, the current I2, and from point A there are current I3, I4 and I5. So the first Kirchhoff law basically says that the total current coming into a point equals to the total current coming out from that point, or mathematically we can write like this: I1 plus I2 equals to I3 plus I4 plus I5. So now look, if we have, let's say, I1 10 amps, and then I2 5 amps, and then I3, let's say 2 amps, and I4, let's say 4 amps. Now based on this law, based on this rule, we can calculate I5. So the total current coming to A here will be 15, and then the current coming out from point A, we have 2 and 4, that's 6, so that I5 will be 15 minus 6, and you'll get 9 amps. Okay, now the second part that I will remind you is about the voltmeter. That's basically a device to measure the voltage difference. So basically the voltmeter has two probes. Usually they are in black and red, and this probe has to be connected to points. So for example, if you have two resistors, and let's say this is R1, R2, and they are connected to a battery. So for example, this is 2 ohms, this is 3 ohms, and the battery is 10 volts. So if we have this situation, you can calculate that the total resistance will be 5. Basically that's just the total of this resistance, 2 and 3. So you have 5 ohms in total, and then you have the voltage difference of the battery 10 volt, and by using I equals to V over R, you can calculate that the I is 10 over 5, so 2 amps. Now if you measure the voltage difference between this and this point, let's say it's A and B, you will connect your voltmeter like this. So basically one of the probe here goes to A, and then the second one here goes to B, and this is your voltmeter. Okay, now look, this current will be flowing to this resistor as the same current I, and if you have a current and you also have a resistor, therefore the voltage difference between A and B will be that current multiplied by the resistance, or you get 2 times 2, you have 4 volts. Now what if we want to measure the voltage difference between point here C and D? Again, the same setting. Basically you will put your probe of the voltmeter to point C and also point D. So let's call it V2. Now look, since this is the same current coming to the same the resistor, basically the current I here, because we don't have branch, so the current is still the same, that's 2 amps. And if the resistance is 3 ohm, basically you can calculate V2 here, 2 times 3, right, 6 volts. Now, you know, the interesting about voltmeter is sometimes you also will be asked to measure the voltage difference between 2 points here, for example, E and F. Okay, so you know, if we have a circuit like this, many times the resistance of the wire can be thought as a very small resistance or close to zero. Therefore, you know, you can imagine that basically between E and F here we don't have a resistance, or the resistance is zero, right? So even though a current flowing into this wire, but since the resistance is zero, therefore the voltage difference between E and F is zero, right? So once you learn about this, you will see that basically the potential of E equals to potential of F. Okay, basically they have the same potential. Okay, so it's different from point A and B because they have potential difference. Okay, so if you write potential A minus potential B, that's this current 2 amps multiplied by this resistance 2 ohms. So the potential difference is 4 volt. Okay, that means the potential of point A is not the same as the potential of point B, and this is very important